We start by giving an example of a Wheatstone bridge. The simplest example of a Wheatstone bridge is a meter bridge. So meter bridge, it consists of a wire of length 1 meter. So this is a wire of length 1 meter. And it has a uniform cross section. So basically means that the resistance per unit length is a constant. And you can say this constant is some lambda. And then you have two resistances here, P1 and P2, and then you have a galvanometer connecting them. So a galvanometer say connects at some point here. So this is a sliding end of the galvanometer. So you slide it till you see zero current here through the galvanometer. That is, current passing through the galvanometer is zero. So once the current is passing through the galvanometer is zero, you know that you have achieved a balanced bridge condition. That is, you have P1 by P2 is equal to L over 1 minus L. So this is the condition for the meter bridge. So ideally we should write this as resistance lambda L over lambda times 1 minus L. So that is the resistance here divided by resistance here, but lambda and lambda cancel out, so you get L over 1 minus L. So this lambda was constant resistance per unit length. So now we discuss an example where we apply this meter bridge to find an unknown resistance. So say you have unknown resistance U, and this U is greater than 2. So you slide the galvanometer wire till you get L and 1 minus L as the length. So from here, if you can read the length of the scale, you can immediately find the unknown resistance. But this is an exam problem, so we are going to solve this. So basically what you do is that the exam problem says that you interchange U and 2. So then you get new lengths L1 and 1 minus L1. But since U is greater than 2, you can see that L1 is greater than L. And this is given to us as L1 is given to us as L plus 0.2. So we just apply the meter bridge conditions. So for the first bridge, you have 2 by U is equal to L over 1 minus L. And for the second bridge, you have U by 2 is equal to L1 over 1 minus L1. So you invert this, you get 1 minus L1 over L1 is equal to L over 1 minus L, and both of these are equal to 2 over U. Now you add 1 to both sides. You add 1 here and you add 1 here. So if you add 1 here, this becomes equal to 1 minus L1 plus L1 over L1, and this side becomes equal to L plus 1 minus L over 1 minus L. So you basically will have 1 by L1 is equal to 1 over 1 minus L. So you invert them, you get L1 is equal to 1 minus L. So this is given to us. You plug this in, you get L as 0.4. So if you get L as 0.4, you plug this back in here. So you get 2 by U is equal to 0.4 by 0.6, and this implies U is equal to 3 ohms.